All right, so I don't even know what slide number we're at now, but there's a slide labeled pancreas. Find the slide labeled pancreas. And that's the one we're going to be picking up on now. Okay, so pancreas is an organ, and you probably don't know much about the pancreas. If I was to say, what does the stomach do? You'd say, that it digests food. And if I said, what does the lungs do? You'd say, gas exchange, etc. But pancreas, what does the pancreas do? Well, I'm going to tell you what it does. It secretes digestive enzymes through a duct out into the digestive tract, and it has islets of Langerhans. It's funny to me, why do there's so many words out there, and yet we find these repeat words, right? But it's just the way science is. Islets of Langerhans are little regions of the pancreas where we have endocrine gland cells. And each one of these cells is going to only produce one kind of hormone. So in the islets of Langerhans, we've got alpha, beta, and delta cells. And so we have three kinds of hormones that are secreted into the circulatory system. So it's not put into the digestive tract. The pancreas has two major functions, digestive enzymes, and then this secretion into circulation of these hormones. And they all have a sort of a direct or indirect effect on blood sugar. It ends up, we have something called the alpha cells. And the alpha cells are going to be secreting a hormone called glucagon. And it's not one that you maybe are really familiar with, but the beta cells, its hormone you will know, insulin. So glucagon and insulin work opposite each other. And so it ends up the glucagon is going to cause you to increase your blood sugar when blood sugar levels get low. Now, don't confuse this with cortisol. Cortisol increases blood sugar levels when you're stressed. That's not what we're talking about. We're saying when blood sugar levels fall, glucagon causes you to pull excess glucose out of your liver. Now, after you eat, though, your glucose levels rise, right? Blood sugar, your blood sugar rises. And you don't want it to be too high. That's called diabetes. So you have insulin that is secreted, and it causes the glucose to be made into glycogen and stored in your liver. So we have these two hormones, alpha cells producing glucagon, beta cells producing insulin, and they're going to be the major controllers of blood sugar. Now, the delta cells. I mentioned somatostatin before, and I'd said it's an inhibitor of growth hormone, and it is secreted by the hypothalamus. It's also secreted by the delta cells here in the pancreas. And I said all of these hormones, either directly or indirectly, are going to be affecting blood sugar, right? And so somatostatin inhibits growth hormone. So what would that do? So what is growth hormone? Let's think. Oh, it causes you to grow, to metabolism, this kind of stuff. If you inhibit that, you're using less energy, right? So somatostatin is indirectly going to be raising blood sugar because it's inhibiting this, growth type activity. Okay, so those are so alpha cells, glucagon, beta cells, insulin, delta cells, somatostatin. We have a few other types of other endocrine glands we're going to be talking about? So we're going to talk about the pineal gland. And this is the third eye. Some occult type groups really latched onto this. I had a student in a general biology class. He thought pineal gland did everything. No, it doesn't. It controls whether you're awake or sleepy. That's really what it does. It's if you're a simple animal, the pineal gland would be something called an ocelli. So like if you're a bug or something, in addition to vision, you have these little sensory cells that are there that are telling you whether it's daylight or night. And it ends up, the pineal gland is going to secrete a hormone called melatonin. And melatonin levels rise when it is dark. Now, last time I looked, I don't have an ocelli. You don't. I'm sure you don't. You're not a bug. Neither of us have ocelli. But what happens is, instead of the pineal gland, being located on top of my head, and I'd have to part my hair around it, it receives information from my eyes. So people that have that seasonally affected disorder and things like that, this is what it's affecting. And if you have that, what do they say to do? You should spend more time in bright light. So control of circadian rhythms comes from the amount of daylight that you're exposed to. And in the dark, you secrete melatonin, which makes you sleepy. Yeah. So if you're having trouble sleeping, turn the light off. It'll help. All right, so we have another endocrine gland that's actually in your chest. It's next to your heart, and it's very active early in development as a child, early in development. And what it does is it's responsible for the maturation of your immune system, certain kinds of cells in your immune system. And it secretes, it's the thymus. And what does the thymus secrete? Thymosin. So in you and I, though, as an adult, I'm assuming you're an adult. Yeah, I think everyone in my class, you look like adults to me. In you and I, the thymus isn't active. You can cut that thing out and it won't hurt you. Now, it might hurt you if you cut your heart out, which is right next to it, but the thymus isn't active at this point. It's already done its job. You've already matured your T lymphocytes. Now, in a child, it's critical for life. So the thymosin is critical for survival because it is involved in maturation of certain parts of your immune system. So that's what thymosin is, the hormone produced by the thymus. Okay. The final slide is like a segue. It's a segue into the next two chapters. And what it is talking about is the other endocrine organs, the testes, the ovaries, and the placenta. The placenta is like when you're pregnant, the baby's connection to mama, that's the placenta. So the ovaries, they secrete estrogen, and estrogen is what produces female characteristics, breast, and so forth. And it also produces progesterone, and what progesterone does is it causes the lining of the uterus to develop and be maintained. And that's in case, as a woman, if you got pregnant, you want that lining there because the baby has to be able to implant in it. And the placenta also is going to produce progesterone, which is, again, maintaining the lining. And we'll talk in great detail about these next week. So that's ovaries and placenta, and then the testes are going to produce what? Testosterone, and that's the masculinizing hormone. It ends up, one final little story here, it ends up that at 7 weeks post-fertilization, as a tiny fetus, if you're a boy, if you're a guy, you started producing testosterone. And that's what changed me from a girl into a boy. It's the masculinizing effect. By default, everyone would be female. It's the effect of testosterone on early development that causes the ovaries to migrate down into the scrotum and the clitoris to become the penis and things of that sort. So anyway, the testes are going to be producing testosterone. So that brings us to the end of the chapter. So if you have any questions on this on Monday, we'll have time to talk about it. And next week, because remember, we have a holiday this week, so it's a short week. No class on Wednesday. This is the only class this week. And so next week we'll talk about the 2 reproductive systems, and we'll get an exam stuck out there. And we'll have to start thinking about the upcoming final. We're almost to the end. Anyway, you guys stay safe. I'm serious about that. There's a lot of COVID out there. So stay safe, and I'll see you on the other side of Thanksgiving. All right. Have fun, kids.